Learners, I am Dr. Prabhat Dwivedi, Associate Professor, STEP-HBTI, Kanpur, India. Today I am going to discuss with you Z-test for two proportions. So let's see how it is done. As usual, I am reminding you that Z-test is conducted in the following situations. One, sample size should be greater than or equal to 30, that is for large samples. Population should be normally distributed, and since here this is for two proportions, population proportions, so both the populations should be independent of each other. And last but not the least, the samples should be randomly selected. So that randomness condition is essential. So that is what the prerequisites for the Z-test is. Let's see what types of Z-tests and how many we have learned so far. We have learned Z-test for one sample and two samples along with Z-test for single proportion. Today we are going to learn Z-test for different proportions or two proportions, and then next lecture will be on Z-test for equality of variances. So let's see how Z-test for difference of proportions or for two population proportions will be conducted. Let's see what Z statistic is for two proportions. Here, what for the test is given to you. A two proportion Z-test allows you actually to compare two population proportions and test it for their equality, whether the two population proportions are equal or equivalent or not. So that is what the null hypothesis is, that the two population proportions are equal. That is, the null hypothesis is of no difference. Equality of two population proportions means of no difference. So other ways null hypothesis can be stated like no difference between two population proportions. Now the test statistic is this, which we are seeing over here. Z equal to P1 hat minus P2 hat minus P1 minus P2 upon root P naught in bracket 1 minus P naught in bracket 1 upon N1 plus 1 upon N2. Again, just recall what the statistic is, what the test statistic is. That is difference upon standard error. So the numerator here shows you the difference of population proportions and populations proportions observed from the sample. That is the difference between the two, and the denominator denotes the standard error. So that is what Z statistic for two proportions is, where P naught denotes x1 plus x2 upon n1 plus n2. x1 means observed values for sample 1, x2 is observed values for sample 2, n1 is sample size of first sample size of the sample 1, n2 is size of the sample 2. So that is what we need to calculate for our Z statistic. That is what the P naught is. P1 hat and P2 hat are observed sample proportions. P1 minus P2 under null hypothesis is 0 because the null hypothesis is of no difference. No difference means P1 minus P2 equal to 0. N1, N2 sample sizes. So that's how you can see the Z statistic is. Now let's see what null hypothesis will be, what alternative hypothesis will be in this case. So null hypothesis, as I told you earlier, null hypothesis is of no difference. That means P1 minus P2 equal to 0 or P1 equal to P2. And against that, alternative hypothesis have three choices. It has first choice of P1 is not equal to P2 against P1 is equal to P2. So first alternative hypothesis we can formulate against our null hypothesis is P1 is not equal to P2. Another is P1 is greater than P2. Still another is P1 is lesser than P2. So when, as I told you earlier, there is sign of not equal to in alternative hypothesis, we conduct two-tailed test. When the sign in alternative hypothesis is greater than, we conduct right-tailed test. When the sign is of lesser than, we conduct left-tailed test. That's how the tails of the test is decided. Now let's see how we will work out a problem related to the two proportions of z-test. So the problem is like a car manufacturer aims to improve the quality of products by reducing the defects and also increase the customer satisfaction. Therefore, he monitors the efficiency of two assembly lines in the shop floor. In line A, there are 18 defects reported out of 200 samples, whereas in line B, 25 defects are reported out of 600 samples of car. At alpha 5%, you have to test whether the difference between two assembly procedures are significant or not. I hope you have gone through this problem. I read it very slowly so that you can write it. So now here we can see what is given to us. 18 defects out of 200 samples. So 18 is x1 and 200 is x2. 18 is x1. 200 is n1. In line B, 25 defects. So 25 defects observed value for in sample 2, therefore it is x2. In 600 cars, that means this is size of sample 2, so this is n2. So in this question, x1, x2, n1, n2 given, and also given alpha level, that is 5%. So these are the values which are required to us, and we have to test whether there is any significant difference between the two assembly procedures. So the null hypothesis is no difference. So against that null hypothesis, our problem shows that there would be two-tailed tests, because we have to test alternative hypothesis that there is difference. Question is not indicating any side, left or right, greater than or lesser than. That's why our alternative hypothesis will be of not equal to sign. So let's see how we will work out this problem. As I told you earlier, the 5-step hypothesis procedure. So according to that, step 1 is state, null and alternative hypothesis. So a null hypothesis is two proportions are the same. Against that, the alternative hypothesis is two proportions are not the same. Mathematical representation of these alternative and null hypothesis are given below. That is, null hypothesis is P1 equal to P2, that is P1 minus P2 equal to 0. Whereas the alternative hypothesis is P1 is not equal to P2. So that is what step 1 is. Step 2 is of level of significance that is given to us 5%, no issues. Step 3 is calculated critical values. As I told you earlier, test statistic is Z as size of the samples are more than 30. Both samples are large, 200, 600, and alternative hypothesis has not equal to sign. So this is two-tail test. So here we will check the critical value for Z two-tail test at 5% level of significance. So that is plus minus 1.96. You may recall it that in two-tail test there are two critical values, one for left side, another one for right side. That means the graph has two side rejection regions and the middle region is acceptance region. So left side rejection region is separated with the help of negative critical value. Right side rejection region is separated with the help of positive critical value. So negative critical value here is minus 1.6, whereas positive critical value is plus 1.96. So let's proceed for the step 4, that is computing value of test statistic. So we compute here for P1 hat and P2 hat for assembly line A and assembly line B. So just recall the given values to us. Here P1 hat is x1 upon n1, that is 18 upon 200, that gives you 9% or 0.09. P2 hat is 25 upon 600 because there the defects were 25 out of 600 cars checked. So 25 upon 600, that value is 0.0416. So the line B value is P2 hat, that is 4.16%. Now we can check P naught, that is the formula is x1 plus x2 upon n1 plus n2. That produces the value 5.37%. Now we put all these values in a Z statistic that is given over here. We can put the values in this formula. So when we put the values, this result into 2.62. So here we can find that the value of Z statistic is 2.62. 2.62 we can check here. Now the calculated value of Z is 2.62. Now let's proceed to the next step of hypothesis testing, that is making decision and drawing conclusion. Here we compare the two values, calculated value of Z with critical value of Z. So with the help of this graph we can see, graph shows you two critical regions, that is one left side rejection region and another is right side rejection region. Since here we have one critical value Z minus critical value Z alpha by 2, that is minus 1.96. Another value is of plus side, that is Z alpha by 2, that is 1.96 plus. So both left and right side have rejection regions. If the calculated value of Z is bigger than minus side value of 1.96, or if it is bigger than plus 1.96, then the null hypothesis will be rejected. So we can check here, Z calculated is 2.62, whereas Z critical is 1.96. So Z calculated is greater than Z critical. That means the null hypothesis will be rejected. So in that case, what the decision and conclusion will be? Decision will be like, since the calculated value of Z is greater than the critical value of Z, so it falls in the rejection region, obviously. Hence, we reject the null hypothesis. In graph, we can very well see our calculated value is 2.62 6,2, which is here, pointed here. So that falls in the rejection region, red zone. That means we will reject the null hypothesis, and in that case we accept the alternative hypothesis. So we fail to reject the null hypothesis. This is how the decision will be written. So what will be the conclusion here? Conclusion will be like, there are enough evidences to support the alternative hypothesis, so we can conclude that there is significant difference. There is significant difference between two assembly procedures, assembly line A and assembly line B. So that's how we will work out a problem of hypothesis testing in two proportions z-test. Now learners, let's take another problem for practice. You will work out at home. The problem goes like, a magazine, I'm again reading it slowly, a magazine reported the result of an online survey of 800 adult Indians. The question asked was, should a tax on tobacco and cigarettes be raised to pay for healthcare reforms? The sample of 800 Indians comprised of 195 smokers and 605 non-smokers resulted into that 351 non-smokers and 51 smokers responded in S. That means they said the tax should be increased. 351 non-smokers and 41 smokers said it. Now we have to test whether there is any significant difference in the opinions between two populations of smokers and non-smokers at 5% level of significance. I expect you to work it out on yourself. Learners, I hope this video lecture will have been helpful for you to clarify the doubts related to the z-test for two proportions. So if you find this video lecture worth, you can benefit your classmates as well as your friends, colleagues by sharing this video lecture with them, because knowledge sharing is very, very productive and pious work. So with this, I would like to thank you all. Thank you so much.